Today lessons, we continue with earned value analysis and EVA 2. Before we get into the detail of today's lessons, I just want to show you so far we learned the project scheduling, planning, and when the project in the progress, we want to evaluate whether the project behind or ahead of schedule, under or over budget. So that is the purpose of the earned value analysis that we discussed in the previous lesson. And today lessons, we use this method EVA to do the performance analysis and forecasting. And with that, why it's important, I use a case study that is Duke Edward Sport power plant project that I introduced to use throughout the semester from the very first day of class until almost the end of this course about the project. In this case, I show you some progress report. It means that the project already under design and construction. And this report, for example, April 2010, and you see the table of content include many information. And let me go through a few of them that show the purpose and motivation for the knowledge, the tool that we introduced today, and the previous lesson, earned value analysis. So first, the executive summary, and you can see if it on the top left, we see the accidents, the safety, and also the progress. And you see the overall, what is the risk baseline, what is the plan that you have planned to complete today. The overall is 64.09%, and you can see here. And then the actual completed 60.83% is mean that we are about 4% behind schedule, and that the mean here is 4.6% there. And then go into detail about engineering, because this time April 2010 is already in construction, so the engineering is still going but almost complete. That was the plan in 94.33%, and the actual completed is about about 0.6% less than the actual the plan, and you can see 93.78%. So engineering, and then procurement 82% about to supposed to be complete, but now it only 79%. Construction is supposed to 38.75%, and it is actual completed only 34.29%. So all of this indication is mean that this project is behind schedule. So that is the time wise problem of this project, the schedule problem. And if you look into further, we can go to display the progress curve, and that we plan to do it today to product 2 for the progress curve. And in this one, as you can see, we have the overall curve of the project, and for somewhere in the middle, that is the solid line, the red line here, and you can see April 10. So that is the status date. All of that on the left is actual, and then we can do the forecast. And in this year's project, they do the forecast in here, and for each line, the purple original plan, and then the light green dot, it re-baseline plan. What does that mean? It means that when the project is so much behind, we need to re-baseline, to need to change, to update the reality of the performance of this project. So that call it re-baseline compared to the original baselines. And the actual is the red, and you see the forecast is something after April 2010 for this report. So that we plan to do that today with the earned value analysis, and that we can go into detail for all other type of work that this project show you. And if we talk about the costs, we have the same project cost control. So it means something in the middle of the project under design and or construction, we have a cost control. And this is the time is January 15, 2010. And again, we have executive summary, KPI, key performance indicator report, contract summary reports, progress curve. And I just go to a few here. And in some of the costs, you can see the budget, like budget at completion, BAC here, 736 million. And the incur today, the actual cost, about 243 million. Project forecast 758. It means that it's about to over budget at this time of the report compared to the budget 736, forecast 758. And in terms of the progress, as you can see, plan is about 42%, the forecast 33, and the actual 35, and the actual is also about 35%. So that we have all the information. Let me go to the costs control, contract summary report for various contract here with many description of the contract, as you can see in there. And then we have the contract number, but my point to emphasize for this one, as you can see, the original contract amount, the changes to the contract costs, incur costs, which is the actual, and the earned costs. So all of that here, so in this summary. So that is the cost control to see whether the cost be high and or over budget. And then we can do that for all other item of the cost, and then we can summarize to see the project. And again, we can have progress curve plan for this project by the day January 15, 2010 is plan is 41.95%, the actual 34.70%, so that you can see the project is really behind schedule, over budget in this situation. So with that example, I go back to our today class. We see the unvalue analysis. To do that, we have to introduce various terminology that we use in unvalue analysis today, as you can see, and so you need to familiar with that. So the variances, in terms of variances, we have a schedule variance, SV, cost variance, CV, and variance at completion, VAC. In terms of the indices, we have schedule performance index, SPI, cost performance index, CPI, and to complete performance index, TCPI. Instead of explaining in here this indicator, go to the problem from 1 to 3 in today's. I explain and what is the meaning behind with the example. For the forecast, we have, if we forecast the time when the project likely to finish, we use the time estimate at completion, EAC sub T. Estimate at completion, EAC, and estimate to complete, ETC. And we have various equations to determine for the unvalue analysis in terms of the performance. We have a variance at completion equation there, SV, CV, to complete performance index, CPI, SPI, and EAC. And to interpret with those information at the certain update date, example in the report here, the update is April 10, 2010. Then in this one, if we find out CV and CV, CPI, or SV, SPI, so we have different scenarios for that. So we have one is schedule and for the cost. So we can see that if the SV or SPI, SV greater than 0, SPI greater than 1, the first column here are ahead of schedule. If SV, schedule variance equals 0, schedule performance index equal to 1, it all schedule, the second column. And then the last column, SV, schedule variance negative, SPI, schedule performance index less than 1, it behind schedule, the last column. In terms of the row, you can see about the cost variance CV, CPI, cost performance index. If it greater than 1 for CPI, greater than 0 for CV, or under budget. That is the first row you see here. The middle row, CV equals 0 or CPI equal 1 on budget for the middle row. And then the last row, CV less than 0, CPI less than 1, over budget, red. So it's not happy phase. Something move in here ahead of schedule, under budget is the very happy phase. And then at the bottom right corner, very unhappy phase because both behind schedule and over budget. So when you see that status at certain point, we know ahead of schedule, so we can make a corrective action accordingly. Then let's go to the some slide that we have, and I show you how to use that information to do in the practice problem in today's class. So just repeat that: variance, indices, and forecasts. And on information, I just put in the note and equation also available in the exam, that exam 3 reference that I'm going to introduce at the end of this slide. So talk about the CPI and SPI, the cost performance index. Typically in here, we put in the vertical axis, and schedule performance index. SPI, we put in the horizontal. And the origin here, keep in mind that it's 1, 1, not 0, 0 at the Cartesian coordinate as we learned in the math, right? So with that here, we can, if we track over time with different update, what's going on with this project, we can say that with these two indicators, two indices. Example, it go down to this way, it means not in good track because SPI and CPI is less than 1. Over budget, behind schedule. Come to this way, we still over budget, but ahead of schedule because SPI greater than 1. In this case, in a good side, week number 3, move to week 3, under budget, ahead of schedule. Even better, under budget, ahead of schedule. Under budget, ahead of schedule. Go to this, week number 6, it will be under budget, behind schedule. So when it under budget, behind schedule, then we under budget, so you still have money. Then it probably you can use that money to put more overtime work, pay premium to bring the project back on track in terms of the time. And this one, good, week 7. Project manager can take vacation because that is the ahead of schedule, under budget. Then it go down to here. The project manager in this case have to go back from vacation to correct the status of the work because this one now here behind schedule and over budget. So that is the we can use do this kind of information to see the dynamics of the project performance throughout the course of the work in problem 2 of today's lessons. And for the forecasting, what's going on when we complete the project. So we have a series of questions, and we can use unvalued analysis to answer that. Are we ahead or behind schedule? We use schedule variance. How efficiently are we using our time? It use SPI. When are we likely to finish the work? We have time estimate at completion, EACT. How are we doing with the cost wise? So cost analysis and forecasting. Are we under or over budget? We use CV, cost variance. How efficiently are we using our resources? CPI, cost performance index. So similar to schedule we have here for the cost. How efficiently must we use our remaining resources to complete performance index? What is the project likely to cost? EAC, estimate at completion. Will we be under or over budget? VAC, variance at completion. What will the remaining work cost? ETC, estimate to completion. So those questions your question. Last 4 questions in the cost wise, and the last question in the time wise, time estimate of completion, we demonstrate that in problem 3. For SPI for the first 2 questions in the time wise, and for the first 2 questions in the cost wise questions, we do that in problem 1 and problem 2 for today's class. So keep that in mind so that you can know what question we can answer. And the equation for different of that measure is shown here in this slide and also available in the exam 3 reference. And we can be able to see the progress, the curve that I just showed you in the Edwardsport power plant project, the case study that I showed you throughout the semester. And in this case here, we can drop at the beginning, the baseline, that is the plant value. And the total of the plant value, we call BAC, if you recall that in the previous lesson, budget and completion. And when the project start, we can update the status of project. And of course, we have to consider contingency because there are many uncertain. We may need to put contingency, something you did in project 1, contingency on top of the cost. And at a certain time, at present day, we can update what's going on with the earned value, EV, and either this gap here between the plant value and earned value. In this case, the plant value at the present day is more than the earned value. That show the schedule variance, and that show the project behind schedule. And whether we measure the delay in this scenario, is the gap between here for the horizontal axis, or we measure the delays at the end. So in this case, we tend to measure delay at the end. That told you at the end of the day, or the bottom line, how much the project is delayed, and forecasted delay that you can see there. So that is the forecast, and that we do in problem 3 of today's lessons. And we have the project progress. We have to spend money, spend resources to complete the project, and that show in the red line, AC, actual costs. And then we see the difference between the actual cost and the earned value. In this case, at the present time, we spend more than what we earn. So the CV is negative. It means we are over budget. And we can, with that, we can forecast what is the cost at the end, and that is called estimate at completion, EAC, in terms of cost, and then the over budget or the cost overrun on top of contingency that you can see there. So that is the forecasting, and we do that for demonstrate that in problem 3 of today's lesson. And now interpretation of the performance indices, and we have the CPI, cost performance index, and SPI, schedule performance index. Let's talk about the CPI, cost performance index. What does it mean if the CPI is greater than 1? So I told it earlier, it's good, right? And you apply that in various problems in today's lessons. Specifically, let's problem 1 and problem 2. It means that it may be greater than 1. It may be overestimated the amount of effort required. So it means, okay, the project is over budget, under budget. It may be because when you estimate, you overestimate the amount. So it looks good, but it may be not that way because you overestimate at the beginning. So always we have to look into the root cause of this number, not only just, compare one. Measurement of percent complete is too optimistic. Suppose by this time we complete only 30%, but we measure, okay, 50% complete. So that is over optimistic. It will seem that we complete more than what we have, and then the CPI is greater than 1, but maybe less than 1 because we too optimistic. If we eliminate or can reduce these first two, then we are happy, better than planned productivity, and that we want to looking for. And if it's less than 1, it's just opposite. It may be underestimated at the beginning, or we measure the percent complete is too pessimistic. it finished 30%, but you say, oh, only 20%. So it reflects the performance, in this case, the cost. It goes to remove, then the poor than the planned productivity, which means that something we need to be done with this project. Otherwise, the project cannot be back on track. The last slide that I want, so interpretation of performance index in this case is the SPI, Schedule Performance Index. Similarly, if it's greater than 1 for SPI, it can be maybe you started to work prior to the or out of sequence to the logical constraint, so you start early, or you better than planned productivity, that's good, or you working on critical activity, so that is good if it's greater than 1 for SPI. If it's less than 1, you can maybe it understaffing or under equipping activity, make slow down the work, or delay in starting activity. Instead of start today, say okay, hope for the weekend, start next week. So that delay works is more difficult than planned, so that may happen. So we tend to be optimistic in the estimate the progress, and when we get out, we face the weather, the rock, things like that, or improper sequencing of activities. Work out sequence will reduce productivity and then the project time. Work is disorganized, not good planning. It's not good for anything, including the project schedule. And that's why we learn this class. And it's beneficial for any kind of major, any kind of practices that you do in the future of your career, engineering, consulting, construction, etc. So that is the unvalue analysis, and you have a chance to apply this method in the 3 problems, and then apply that in the software for problem 4 in today's class. And by the way, and you can see the exam preference. If you go to the first page, very end, you can see that the unvalue analysis for each equation and different terminology with the abbreviation, so that you can use reference for your quizzes and exam.